This is slide number 8 and I am your presenter Asloob Mudassar. We have discussed some BATOs, that is binary amplitude transmission objects, in the previous slide. Now we are presenting them in the circular form. So you can see that different slits of varying thickness are shown along from left to right, and in the first row, and in the second row we have shown some two BATOs which are the negative of the second last object. So notice them very carefully. Now here we present BATOs that can be used, that have been used in order to check the quality, of low resolution optical systems. So these are shown. On the left we have the spoke target, and on the right we have the USAF targets, the United States Air Force targets. So the United States Air Force targets is an old target, is an old resolution chart, and you know that contains different bars of different thicknesses and different spacing between them, and these can be used in order to determine the resolution of low quality optical systems. But on the right we have the spoke target. The spoke target is very special target. You can see that in the center the spatial frequency is very high. Spatial frequency means line pairs per millimeter, and line pair mean that clear line and the opaque line, these two lines together make line pair. So line pairs per millimeter are much large, is a great number in the center, but as you go away from the center you will see that the spacing between the transparent lines and the black lines will increase. It means that their spatial frequency will decrease. So the spatial frequency for the spoke target is highest in the center, and as you go away from the center the spatial frequency will continuously decrease, and ultimately at the edges it will come to some minimum value. But in the and you know that spoke target provides you a continuous range of spatial frequencies. So high in the center, as you go away from the center the spatial frequencies will decrease, but decrease in a continuous fashion, and you know that at the edges it will reach, that is the spatial frequency will reach to its minimum value. But in the USAF targets you can see that different bars of different thicknesses are shown. And in the center you can specially see that the bars are very narrowly placed, and the spatial frequency is very high in the center, but at the outsides we can see that the spatial frequencies are low, but this object has discrete values of the spatial frequencies. So in the center the spatial frequencies are higher, and in the outer periphery the spatial frequencies are low. But you know that these are varying not in a continuous fashion but in a discrete fashion. So we can use these two targets, that is the spoke target or the USAF targets, in order to determine the performance of a low quality optical systems. So here this is the end of slide number 8.